Next time you go for an X-ray, you would remember this video. Ah, what exactly is an X-ray? For those of you who don't know who this is Pikku. Most people think of X-ray as something doctor used to look at broken bones. But in reality, an X-ray is just a special type of light. Sound strange, right? You see, visible light, the color you can see like red, green, and blue, is only a tiny part of something much bigger called electromagnetic spectrum. Radio wave, microwave, infrared light, ultraviolet light, X-ray, and even gamma rays are the part of same family. The only thing that really distinguishes them is their wavelength. As wavelengths get longer and longer, we move toward radio and microwave. As it gets shorter and shorter, light becomes more energetic and eventually we reach X-ray. X-ray have extremely short wavelength, smaller than the atom itself. Then most of the sunlight is invisible to us, right? Hmm. Yes, Piku. Our eyes are only sensitive to a small range of wavelength that we call visible light. Sun actually emit across a much broader range of electromagnetic spectra, including infrared and ultraviolet light. But its emission peak in visible part of the spectra. Oh, what if some source have its peak in X-ray? Yes, sources like those exist. These are ULXs. You know what? They have luminosity, or in other words, power that is 10 to the power 39 ergs per second, whereas our sun has just 10 to the power 33 ergs per second. Ah, if our sun was like that, we would survive that, right? Right? You can't survive the Delhi hotness that's like 45 degrees as of now. Do you think if our sun was 10 to the power 6 times more luminous, then you would survive that? Relax, Piku. If one of these objects were present in our own galaxy, astronomers would be talking about it unstop. As far as we know, there is no confirmed ULX in our Milky Way, but in other galaxies, these mysterious objects are surprisingly common. Take the galaxy M51 for example, and before you ask that name does sound like a Samsung phone model, there is actually an interesting history behind how astronomer came up with these names. So if you would like to have a video on that, let me know in comment section. Anyways, back to the story. In an ordinary optical image, this helix looks completely unremarkable. It bends in with the countless stars around it, and nothing seems special about it at all. But switch to an X-ray view, and suddenly it becomes one of the brightest object in galaxy. X-ray image of this galaxy is like X-ray image of my knee, right? No, Pico, no. In this case, X-ray come from a machine, passes through your body, and are detected on the other side. Soft tissue like muscles allow many of X-rays to pass through, while bones absorb much more of them. The result is essentially a shadow image of inside of your body. But when astronomers talk about an X-ray image of a galaxy or a star or anything, they mean something completely different. There is no X-ray machine shining through the object. Instead, the object itself is producing the X-ray, and the telescope simply collects those X-rays that are naturally arriving from these sources. So that means that these sources can give me free X-ray scan. Piku, you already know how uncomfortable it can be to stand under afternoon sun for too long. Now imagine increasing the power output by the factor of a million. If you were close enough to receive that kind of radiation, survival would be the least of your concern. You won't be getting tan, you will be getting vaporized. And if you think, fine, I will just stay further away, that's much better idea. The intensity of radiation decreased with distance, so there is always some distance at which incoming energy becomes smaller. But remember, ULX doesn't emit just ordinary light. They produce enormous amount of high energy X-ray. Prolonged exposure to intense X-ray field is extremely harmful to living tissue, damaging cells and even DNA. Fortunately for us, these objects are located in other galaxies, millions of light years away. By the time their X-ray reaches Earth, their radiation is incredibly weak. In fact, the flux that reaches the ground is far too small to perform anything like medical X-ray scan, and that's a very good news. Because if Earth were being showered in this intense ULX level X ray, life as we know, it would have been a serious problem. These sources are going above my head. What are these sources? ULX are non-nuclear accreting X-ray binaries with luminosity greater than 10 to the power 39 ox per second. Ah, stop it! Your singing doesn't make it easy for me to understand this definition. I know that, Piku. Let's break down the definition into Eddington limit, non-nuclear, and X-ray binaries. From starting of this video, I was saying that ULX have output power greater than 10 to the power 39 ergs per second, but where does this number come from? Okay, Piku. To understand that, let's go step by step. So, from quantum mechanics, we know that photons have some momentum, which leads to force. So, yes, light can apply force too, and this force is named as radiation force. Imagine matter falling onto a compact object such as neutron star or a black hole. Gravity pulls the matter inward, but as this matter falls in, it heats up and emit enormous amount of radiation. This radiation pushes outward. So we have a tug of war kind of situation, gravity pulling in and radiation pushing out. If source become brighter and brighter, this outward radiation force also becomes stronger and stronger. And eventually, a point is reached where the outward push of radiation exactly balances the inward pull of gravity. At that moment, any extra increase in brightness would push the infall matter away. This means that for a given mass, there is maximum luminosity the object can sustain while still accreting matter. That's maximum luminosity is called Eddington limit. By doing this calculation, we get the Eddington luminosity equal to 1.3 into 10 to the power 38 m by m naught, where m naught is the mass of sun. So for a source whose mass is 10 times the solar mass, it would then give Eddington limit in orders of 10 to the power 39. That is all what we were talking from the starting of this video. Oh, the holy shit! How these ULX are breaking this limit? I know. Maybe the source's mass is like supermassive black hole whose mass is millions to billions times the masses of sun. So its Eddington's limit would be increased to millions or billions time more, and then they can easily crack that 10 to the power 39 limit that we have set. That is just for 10 solar masses. That's where things starts getting interesting. You know, all these ULX that we have discovered, all of these are non-nuclear. So we can't have a very massive object who powers them. What? Why does the definition say it is a binary system? What's bad about being single? Don't get personal, Pico. In binary system, a normal star and a compact object, either a neutron star or a black hole, orbit each other. The compact object pull matter away from its companion star. However, this matter doesn't directly fall onto compact object, instead it spirals around it, forming what is known as accretion disk. As the material moves inward through the disk, it falls deeper and deeper into the compact object gravitational field. This means it loses gravitational potential energy. That energy doesn't simply disappear, it gets converted into heat and motion within the disk, causing the gas to reach extremely high temperature. At this temperature, this begins to emit enormous amount of radiation, especially in X-rays. Now compare this with an ordinary star like our sun. Sunshine, because the nuclear fusion in its core convert hydrogen into helium, the energy produced in the core slowly makes its way to its surface and eventually emitted as light. Whereas accretion is completely different in reason. In fact, converting gravitational energy through accretion is far more efficient than producing energy through nuclear fusion. A given amount of matter falling onto a neutron star or a black hole can release much more energy than the same amount of matter undergoing fusion inside the star. And that's the key reason ULX are almost always associated with binary system. The extreme luminosity we observe require a continuous supply of fresh material. A lone star simply cannot provide that much energy on its own, but compact object constantly feed onto companion star can. And that's how we get this definition of ULX that are non-nuclear accreting X-ray binaries with luminosity L greater than 10 to the power 39 ergs per second. But that still don't answer that how these ULX exceed Eddington limit. To understand that we have to know about sorry, I have to do my assignment. So let's cover this topic into our next video. Till then, keep questioning, keep thinking, and do whatever you want. Bye bye.